Okay, picture this. It's a scenario that literally strikes fear into the heart of almost every software engineer. You know the drill. You're just sitting at your desk, sipping your morning coffee, and suddenly the alerts start absolutely screaming. The application is down, users are getting errors left and right. You, my friend, are facing a broken production environment. So you look at the logs and realize 3 deploys happened today. Production is totally broken. The golden question is, which one caused it? Now, normally this kicks off a completely chaotic war room situation, right? Everyone's scrambling, people are pointing fingers, there's a whole lot of guessing going on. But today in this explainer, we're going to look at a calm, methodical, and purely data-driven way to answer this exact question using Sentry release tracking. We're essentially looking at 2 completely different realities here. On one hand, you have the old way, investigating blindly by digging through endless, raw text logs, frantically trying to cross-reference timestamps with GitHub commits. It's a nightmare. It really is. On the other hand, you have the enlightened approach, pinpointing the exact code with Sentry release tracking. Instead of guessing, Sentry's deployment context gives you the exact answer. But, well, before we solve our big production mystery, we kind of need to understand the tools at our disposal. So let's jump straight into defining Sentry releases and your CI/CD setup. First things first, we need to define our terms. What exactly is a release in Sentry? Well, it's a discrete version of your code deployed to a specific environment. Think of it like drawing a really distinct, hard boundary around a specific set of code changes. By telling Sentry, hey, this exact bundle of code right here, this is version 2.4.1, you unlock some absolutely incredible features. Specifically, you get commit tracking and regression detection. So how do we make this magic actually happen? It's basically 3 super straightforward steps to configure your CI/CD pipeline. First, you just add your Sentry auth token as a secret in your pipeline, like, say, in GitHub Actions. Second, you run the Sentry CLI tool. And third, and guys, this is absolutely crucial, you use the CLI command setcommits --auto. This automatically tells Sentry to grab your Git history, figure out exactly which commits are brand new in this deployment, and associate them with this exact release version. Once you've done this, Sentry isn't just tracking errors anymore, it's tracking exactly who wrote the code that caused those errors.
All right, let's move right along to monitoring release health.
Okay, 92.1%. Let that number sink in for a second. This is our crash-free session rate. Now, normally, our app runs at a really smooth 99.2%, so seeing this suddenly drop down to 92.1 is a giant flashing red light. To put that into perspective, it means that nearly 8% of our active user sessions are currently ending in a hard crash or an unhandled error. And the beautiful thing is, the release health dashboard in Sentry gives us this macro-level metric instantly. It signals a critical anomaly in the wild without us having to write a single custom query. And this tells us exactly where the problem originated. We can clearly see our 3 most recent deployments. Version 2.3.9, error rate is super low. Version 2.4.0, also low, looking totally healthy. But notice version 2.4.1. There is a massive spike in errors that perfectly correlates with the exact moment that specific release went live. Sentry has essentially handed us the very first piece of our puzzle. We now know definitively that deployment v2.4.1 is the one that broke production. Which brings us to our scenario. Debugging version 2.4.1. We have our culprit release, so let's zoom into a real-world sandbox incident and see how fast we can find the exact line of code. Just look at the timeline of our actions here. At 1400, the error spike is detected via an automated alert. By 1402, we've jumped into the release health dashboard and identified v2.4.1 as the bad actor. At 1406, we've clicked into the release details to look at the commit diff, seeing exactly what code changed. And boom, by 1408, we have isolated the root cause. 8 minutes. That is the pure power of having your telemetry deeply, deeply linked to your version control.
And while we're navigating around, we noticed something else that's really interesting. This specific error was automatically flagged as a regression. Let me explain why. Because Sentry's regression detection engine is actually incredibly smart. When you fix a bug, you can mark it as resolved in current release, resolved in next release, or resolved in a specific commit. If Sentry sees that exact same error happen again in a version number higher than the one where it was supposed to be fixed using semantic versioning logic, it immediately flags it as a regression. In our scenario here, this bug was actually supposed to be fixed last week, but our 2.4.1 deploy accidentally reintroduced it. No way, right?
And now, for the best part, finding the suspect commit. We know the release, we know it's a regression. Now we trace it back to the exact code. So how does Sentry do this entirely on its own? Well, it uses a pretty rigorous algorithmic logic behind the scenes. First up is in-app frame isolation. It strips away all that noisy third-party library junk in the stock trace and finds the topmost frame that belongs to your actual application code. Second, get blame analysis. Sentry takes that exact file and line number from the stock trace and queries your source code management to see exactly who last modified it. And third is recency filtering. It actually ensures the commit was authored within the last 12 months, so it doesn't accidentally blame someone for some legacy code that was just, an innocent bystander to a much newer bug.
And then right there on the issue details page, Sentry just gives you the answer. Suspect commit identified. Race condition in authentication flow introduced by developer X. It's almost like magic. We have the exact commit hash, we have a link directly to the pull request, and the author's name. There is absolutely zero guesswork here. We don't have to jump into a panic-stricken Slack channel asking, hey guys, who touched the auth flow today? Sentry just tells us.
Which leads us to the final, incredibly satisfying step in our incident response: assigning the issue to the suggested developer, complete with the full stack trace and commit context. From right within Sentry, you literally just click the suggested assignee. Developer X instantly gets a notification containing the exact error, the breadcrumbs of what the user did leading up to it, the environment data, and the specific commit they wrote that likely caused the whole thing. We have officially turned a chaotic, panic-inducing deployment failure into a highly efficient, perfectly targeted resolution workflow, all in under 10 minutes. So, as we wrap up this explainer, I want to leave you with a final provocative thought to really ponder. How much faster could your team recover if every single production error was automatically linked to the exact commit that caused it? Just think about the hours saved. Think about the frustration avoided and the sheer confidence you gained during deployments. By setting up Sentry release tracking and tying your CI/CD pipeline directly to your observability tools, you stop guessing and you start fixing. Thanks so much for joining me today. Now go check your own repository configurations.